Hello, now I'm going to work on the question 4 and 5 on chapter 16 about redox. And they say in which of these compound phosphorus have the lowest oxidation state. Remember, the oxidation state is the oxidation that any no metal, we can represent a no metal like a X, can be negative n, where n will be 1, 2, 3, 4, or any other number. And in metal, we can represent the oxidation state like a positive n, and the n is again 1, 0. It can be also 0 when the element is in the ground state. Example of that, let's say we can also say sodium can be positive and positive 1, and chloride will be negative 1. So let's find which one of these phosphorus compound will have the lowest oxidation number. One easy way is the following. As you can see on the first one, diphosphorus 3 oxide, we can cross the oxidation number. The 3 represent the oxidation number of phosphorus, and the 2 represent the oxidation number of oxygen. So here in this diphosphorus 3 oxide, the oxidation number will be positive 3 or 3 positive. On the next one, we can do the same thing. 5 represent the oxidation number. We cross the subscript of the sulfur will go up as the oxidation number of phosphorus, and the subscript for phosphorus will go to the sulfide, which is 2 negative. So the oxidation number here of phosphorus will be 5 positive. On the next compound, the rule that I use for finding the first and the second one will not be easy apply, because we have like a trinary. I mean, it's like a compound with 3 different elements: potassium, phosphorus, and oxygen. So we need to find out what will be the oxidation number of this salt that will be potassium phosphate. Here is the thing. I know that potassium is in group 1, so that will be 1 positive, and oxygen in oxide will be 2 negative. So I will make a algebraic equation like this: 3 times 1 positive plus X. We have only one phosphorus, that's why we don't multiply by any subscript here, plus 4 times negative 2. 4 times negative 2. And that will be equal 0. Why equal 0? Because this is a neutral molecule. This is no ion. So solving for X, I will have negative A, and that will be 0. X will be A minus 3, and that will be 5 positive. And that's another phosphorus here will be 5 positive. So the answer will be this one. In this compound, diphosphorus 3 oxide, the phosphorus will have the lowest oxidation state. That will be the correct answer on the question number 4. Let's go to the next one. Number 5. Sodium react with water according to the following equation. Identify the element that is being reduced. Sodium oxidation state is 0 as a metal in the ground state without any compound, without forming any compound, and here will be 1 positive. All the elements in group 1, the alkaline metals in the periodic table, will have the 1 positive. And hydrogen is also 1 positive on the water, and because it's combined with the oxygen here, and oxygen will be 2 negative. And oxygen here will be 2 negative, and hydrogen will be positive. So sodium is going, and we have hydrogen also at the product, that will be 0 here. So sodium is experimenting oxidation, and they asked me for the one that is reduced, so it's not sodium. Let's check hydrogen. Hydrogen is 1 positive, going from 1 positive to 1 positive here, but also is producing hydrogen gas. It's a um, molecule of hydrogen, and the oxidation state for the molecule is 0. So my answer will be hydrogen will be the one that is being reduced. Why hydrogen is being reduced? Because it's going from hydrogen positive in water is going to form hydrogen gas, and that will be where the oxidation state will be 0. So he's gaining 2 electrons in order to become 0. The 2 positive and the 2 negative will make the molecule, and that's the one that is being reduced. Let's go to the next question, and that will be the last for this short video, and that will be number 6. How many electrons are exchanged when this reaction is balanced? So manganese, let me rewrite again the question. Manganese plus chromium 3 in solution, and that will producing manganese 2 in solution and chromium metal. So manganese is going from 0 to 2, so there is losing 2 electrons, and that will be oxidation of manganese. Chromium is going from 3 to 0 and is reducing, gaining 3 electrons. In order to balance this equation, the amount of electron being released has to be equal to the amount of electron the being gained. So I had to multiply manganese by 3 and the chromium by 2 in order making 6 electrons in total being gained and released by manganese. So that will be a 3 here for manganese, a 2 here for chromium, and of course that will be a 3 here for the other manganese and a 2 here from chromium. So the answer will be how many electrons are exchanged when this reaction is balanced? The correct answer will be 6. Briefly, on question number 7, I make a video because it's a long answer compared with the previous one. You need to use the ion electron. Check the previous video that I shared with you, and I balance this equation using the ion electron in acidic solution. So let's stop here, and then we will continue with the rest of the question. Thank you for watching.